Thank you.
Okay, should we get started?
Sure.
Okay, so this session is indoor air quality in a pandemic, keeping your building open and occupied. The session pertains to the COVID-19 pandemic, has put a spotlight on the topic of ventilation strategies and how they impact the indoor air quality of our buildings. This presentation will highlight and prioritize the HVAC modifications needed to help reduce the risk of virus transmission in buildings. We would like to thank Control Technologies for sponsoring this session. Scott Cunningham, Grant Manager with Control Technology, will now have a few words to say. Scott?
Thanks, Mike. Control Technologies is pleased to sponsor the Best Practices Exchange once again. Efficiency Vermont and Control Tech have a long-standing relationship, and we work together to identify where we can improve indoor air quality in facilities across Vermont. We do things like resequencing of control, allowing building operators to choose different modes of ventilation, creating isolation rooms in facilities such as schools where a nurse's room may need HEPA air filtration, in some cases a negative pressure room. We upgrade air filters when feasible to like a MERV 10 or MERV 13. We offer UVC lighting solutions in some cases. And finally, we perform equipment evaluations to identify any other opportunities to improve indoor air quality. And we thank Efficiency Vermont for bringing the BPX to us again for the 9th year, and we're looking forward to getting the most out of this virtual conference. So thanks again, Mike.
Thank you, Scott. We very much appreciate your participation in this event. First up speaking is Rachel. Rachel Mascalino is an engineer with the BEIC's Energy Services Division and has been focusing almost exclusively on helping customers optimize HVAC systems to improve their IAQ over the past 6 months. Rachel?
Great. Thanks, Mike. And thanks so much, Scott, for your sponsorship. I think it's very fitting that Control Tech is the sponsor of this session. Alex and I both have worked pretty significantly with many on the Control Tech team over the last 5 or 6 months now to really make impactful and significant improvements in a lot of facilities across Vermont. So thank you very much.
Yeah, you're welcome. It's great.
So back in January, when we were all able to travel a little bit, I was able to attend the ASHRAE Winter Conference. And one of the things that I really enjoyed about that conference were some of the sessions on case study presentations highlighting the best buildings that have been designed to build and retrofit over the past few years. And it was really interesting for me to learn about the science and the language shift. So the language around healthy buildings is really being included in OPRs. And personally, given my background, I'm always thankful when I hear the conversation is shifting away from what's the least crappy HVAC system I can get for $42 a square foot, and really we're hearing the conversation shift to how HVAC systems can be used and to make occupants of the buildings feel better, and how they can really be used to optimize the experience of occupants in buildings. So this is a discussion on indoor air quality. My point here is that this is not a pandemic response. This is really a shift in engineering and building science that's gained a lot of momentum over the years. And we were pretty far into this discussion before March of 2020. So although this presentation highlights some of those reactions that we're taking now, given our current environment, the idea of healthy buildings and well-performing and optimizing indoor air quality, there's some momentum here. We know that bar for healthy buildings is raised, and we see the shift and the focus and the acknowledgement. Boy, I should have turned that off, sorry. And it was interesting to me to hear that we are an indoor species in terms of humans, but that we spend 90% of our lives indoors. That was shocking to me. That is not the percentage I would have guessed. And I think I'd like to say that as Vermonters, maybe we're significantly below that 90%. But the reality is that buildings across the US, this is the shift in the way that we need to think about how we're really using all the technology that we have access to create a built environment that enhances and promotes and protects our health. So indoor air quality, it's a subset of parameters that are evaluated when people are talking about healthy buildings. I thought this was a good graphic to outline all of those parameters that are brought together when we're talking about healthy buildings. And the research shows us that when all of these are addressed and when all of them are balanced, you have spaces that yield improved cognitive function, improved personal health, and improved societal health of the occupants. Indoor air quality accounts for half of those parameters that are associated with healthy buildings. And this is going to be our focus today, to talk about those tangible improvements and modifications to those systems to improve the indoor air quality and pretty directly the resiliency of our spaces to stay occupied. Today, the indoor air quality discussion, it's all about risk mitigation of viral transmission. So the components of healthy buildings that make up indoor air quality, those have always been part of the discussion, and the facilities that have invested in these systems have the ability to make the modifications quickly and address those concerns around risk. And a pandemic is a good example. It highlights an event that would stress a building's ability to be occupied, but it's not just a pandemic. So this is not, indoor air quality is not something we're thinking about just because of a pandemic. There's also going to be situations where we're at temperatures and conditions that are colder than design days and hotter and more humid than design days. And we know that there are businesses in Vermont where employees don't show up on the hottest, most humid days in the summer because of poor indoor air quality. And I've walked through office spaces, and I'm sure others have as well, in February, where more than half of the employees in those open office areas are wearing down jackets. And it's hard to be at your optimal cognitive function when you're cold and sitting still. And this isn't necessarily what's going to make us sick or increase viral transmission, but it's certainly part of the conversation of having an indoor built environment that is resilient and is going to keep the occupants in a healthy state. And so thinking about those investments in your HVAC system as a component, it's an investment in your business's ability to be resilient. So this current crisis it's testing the resiliency of the buildings across Vermont. And schools, hospitals, office buildings, they're all assessing and addressing their unique risks and their unique indoor air quality requirements. And the good news is that we continue to be able to address indoor air quality and minimizing transmission risk with fundamental engineering principles. So these design parameters that I've listed here, these are the same ones that I've been working with for my entire career and all the other engineers out there. And so building on these for existing buildings, we're helping evaluate that initial design of the HVAC system and understand how that supports the values that we know are best practices today. So these are the typical target values, and these are going to vary depending on, they're going to be different for hospitals and offices and schools. But the point here is that there's nothing groundbreaking or some new technology that we're waiting to be developed to address indoor air quality and minimizing transmission risk. These are parameters and values that have been part of the conversation that Alex and I and others have been having with you all as our customers for years. So if we take those design parameters and focus on the ones that we know can impact potential viral transmission, we can narrow it down to these 5: temperature, RH, air changes, ventilation, and particulates. And this is what we want to focus on now during this pandemic. And for existing buildings and systems, we are following the hierarchy of focus on areas that the Harvard T.H. Chan School of Public Health has released for impact. They ranked it in the highest impact to to transmission risk. So this is why so much of our focus with customers is around ventilation, air changes, and filtration, because we know this is the most significant impact that we can make on transmission risk using the existing HVAC systems. So here is that hierarchy. This is based on minimizing exposure to any contaminants, whether it's this virus or a flu or a cold that would typically we would see in buildings in Vermont in the winter. So intensity and duration can be addressed with ventilation and filtration, and that's why we see these that are right at the top. That formula of exposure equals intensity plus duration plus frequency. That's OSHA, Harvard, CDC. That's something that they're all talking about in terms of trying to weigh the risks of how we're occupying our buildings. And that frequency, that's more about the human behavior. So how long are you in one room, in one place? The screening, the distancing, the barriers, that's all going to go into that frequency component. And that's at the top of the hierarchy. But next is ventilation and filtration. And that's as mechanical engineers and facilities directors, that's what we can have an impact on to make a difference, and how we can use your existing system to minimize those risks and build resiliency. So if we start with ventilation, here's why we care about ventilation. And this is also why we all get sick in Vermont in the winter, when maybe we are spending close to that 90% of our time indoors. And this illustration is I know this is an extreme example. It's a closed box, but it's a way to visualize that invisible effect of why a room might feel stuffy after you're in it for 30 to 60 minutes. There is this buildup of an increasing concentration of the aerosols from breathing and talking that just naturally build up in the air, including CO2. So we want to make sure that we have the necessary ventilation in place based on the activity that's going on in this space and the number of people and the area of that space. Obviously, it's going to be different if you have one person speaking or you have an auditorium where there's 400 people. These are all things that we want to assess in your specific building, and even within zones of your specific building. So if I think of a school, a classroom is going to be different than maybe a cafeteria, which is the ventilation varies between 0 or 100 occupants, versus a classroom where it's a pretty steady occupancy throughout the day. But that ventilation, that's what's going to dilute these aerosols that we see and not let them accumulate. We're going to avoid that stuffy feeling. We're going to avoid the CO2 accumulation. And right now, most importantly, we're going to avoid that concentration of aerosols, which we know is the primary transmission of the COVID virus at this time. So the amount of ventilation that you have in your space, it doesn't have to be a mystery. And one of the things that Alex and I talked about with this presentation is we really wanted to be able to present tangible changes and understanding that the people attending this session could take back to their building. There's so much information out there from the CDC and the WHO and ASHRAE, and it's information that they have to put out that has to apply to every single building across the country. And so it can feel a little overwhelming to weed through that and understand how we can apply that to our buildings in a meaningful way. But this is really the root of ventilation, which is at the top of that priority chart. This is a screenshot from the ventilation rate table from ASHRAE. It's organized by occupancy type. And you can see, you can easily put a metric on what is the minimum amount of ventilation, the volume of air that I need to be introduced to a space based on the type of the space. So here I just picked office space. We know that you need 5 CFM for every person that's in that space, plus an additional 0.06 CFM for every square foot of area. And this is what we're doing with our customers. We're evaluating, helping them evaluate what they have, compare it to what they need, and then look at how ventilation plays into their overall indoor air quality strategy and decide if they want to increase that ventilation for a subset of time. Something you may be hearing is this whole idea of a pandemic mode. So the idea that a building reacts differently when there is an outside environmental impact that could be impacting the occupants. And if we want to put a number on that pandemic mode for ventilation, some people are saying 30% more than that ASHRAE minimum. And some buildings, depending on how sophisticated their control system is, they are saying, let's just bring in as much ventilation as we possibly can, as long as the other indoor air quality parameters are not thrown out the window. So how much ventilation can you provide while still maintaining a space set point that feels really comfortable to the occupants? Because if we just bring in a ton of ventilation air, you're not going to have any accumulation of aerosols, but you're going to drive that temperature down, you're going to drive the RH down, and that's going to impact other transmission risks. So it really is a balancing act. But the point here is to really kind of break it down to that baseline of understanding that there are numbers and this is measurable, and we can help customers or partnering with your HVAC contractors or other engineers. We can put a number on this and help you set goals for where you want to be depending on the situation that we're in. So the next priority is air changes and filtration. And I think about these together because the number of times that the air is passing over the filter in an hour, that's going to impact the effectiveness of that filter to clean the air. The recommendations from ASHRAE and the CDC and Harvard is to increase the return air filters to MERV 13 when possible. And I want to highlight that last bullet there, that filtering the outdoor air at a different level, filter the outdoor air at a different level than the return air. So when we want to keep out the aerosols and the particles that could be transmitting a virus, we know those are created by people breathing. And so putting in really high grade filters for outdoor air is not always necessary. That's not the focus here. MERV stands for the minimum efficiency reporting value. And a lot of people say, why MERV 13? We have MERV 1 all the way up to HEPA filtration, but you can see on this chart that MERV 13 is where we're going to start effectively capturing those small aerosol particles. And these are the respiratory particles in the air that can carry the COVID virus and other viruses in that family. The CDC and Harvard, they break transmission into 2 particle sizes, droplets and aerosols. You see the droplets are 5 microns or larger, and then aerosols 0.3 to 5, and then there's some talk of those smaller aerosols. But it's pretty clear to see that's where that 0.3 to 1 micron range that starts to become effective and kick in right at MERV 13. And so that's why MERV 13 is the target. Another way to think about it is to compare the effectiveness by particle size. So again, the priority is filtering the air that's being recirculated in one HVAC zone. To date, we still do not have contact tracing examples of the virus being transmitted through an HVAC system from one zone to another. So there's a lot of fear of, if I'm in one office area and there's a return air duct back to an air handler and that air is being mixed with other ventilation air through a set of mixed air filters and distributed back into another zone, it doesn't matter where I am in the building, I could still the virus could still be transmitted, and that's not the case. And I think it's the combination of the filters that are replaced, even if they're only MERV 8, and that dilution with that ventilation air that's being drawn in to those air handling units between different zones. So the takeaway points here, I think that regardless of the building type that you're representing, that you might be an engineer or facilities director of, or even just on the facilities team, focus on the key metrics that we know have really been studied, and that's the ventilation, the air changes, and the filtration. It's just so important to understand that all of these components are really interactive. There's no one magic parameter. I have customers who really want to key in on CO2 levels. They want to key in on the MERV rating of their filters, but they aren't really interested in paying attention to the number of air changes, so the number of times that the air is passing over the filters. It's all of that together. And again, this is not about guaranteeing that anyone is going to be exactly safe. It's about how this HVAC system and the indoor air quality plays into your risk mitigation strategy, which plays into the resiliency and the ability of your building to stay occupied during a variety of outside influencing conditions. Keeping in mind that the key metrics that we talk about are those air changes per hour, that filtration, and that ventilation. And this can be simple, right? We can really just bring it back to the fundamentals of engineering and build on what we already know about HVAC systems, good mechanical engineering principles, and the knowledge that our trade allies and contractors have here working with customers in Vermont. And there's going to be systems where there are big improvements that are going to need to be made, big capital investments, but there's a lot of work that can be done to make things better than they are right now. That's going to serve you well in the next year and a half and beyond for the circumstances that we're not even sure what they are yet. So that wraps up my portion. If there are any questions, Mike, that have come in, I think we forgot to say if people wanted to type questions into the chat, I can take a couple questions now. If there are any, we were also, Alex and I really wanted to leave time at the end to make sure that there's opportunity for people to open up the discussion. Mike, maybe you can let me know if any questions have come in. I'm not able to see that.
Yes, there is one question, Rachel. Can you hear me? I just
Yes.
want to make sure my audio is working. Sorry.
Yep, you're good.
So excellent presentation. I just want to point that out. I thought that was extremely informative. There is one question that came in, and it says, how do you address upgrading the filtration when you don't have a separate set of OA or RA filters in a unit? There's only one mixed air filter.
Yep. So what I think this question is getting at is we hear about the need to increase filtration on return air, but there are some instances, there's some equipment where you might not have two filter banks. Your outdoor air might be filtered with the same filter bank that your return air is filtered through. In that case, I have seen customers choosing to go to MERV 13 filters, even though they might not need to, you don't need to filter outdoor air, right? The whole point of filtering the outdoor air with MERV 8 is to keep out the pollens and the particulates and the dust, any contaminants that would just be out in the environment, wherever that intake air is. But we certainly don't need to keep viral size particulates out of the outdoor air stream. Customers they're just right now they're ordering and replacing that comprehensive filter with a MERV 13 if they can. So it depends on the thickness of the filter that they're transitioning to, and what's available for just an easy retrofit. Something to keep in mind is because you've got a filter now that's capturing really, really small particles, that filter is going to get loaded up more quickly. So with all of the pollens and the stuff in the air, you may need to do an extra filter change to be able to make sure you're still getting the airflow that you need through that filter.
Well, that's great. Thank you very much. That's the only question that was submitted.
Okay.
So I think we'll move on now to Alex Rowe. And Alex Rowe is an Efficiency Vermont energy consultant that has been focusing on the IAQ initiatives for Efficiency Vermont customers since July. She'll walk you through an example case study to illustrate specific actions that Vermont businesses are taking to improve IAQ. Thank you, Alex.
Thank you. Rachel, do you mind?
Yep. So I'm going to stop sharing.
Thank you.
And you can click through your presentation.
Okay. Let's see if this works.
And while Alex is getting that set up, if anyone has questions, they can feel free to type those in. And I think at the end, Mike will be able to read those out to Alex and I, or even any discussion points around indoor air quality that people wanted to bring up. That would be great.
Absolutely. Thank you again.
Great. Can everybody see my screen?
Yes.
Great. All right. So thank you, Rachel and Mike, for the introduction. And thanks, Rachel, for that awesome insight into how HVAC systems can play a role in managing and improving indoor air quality. Good afternoon, everybody. As Rachel mentioned, as Mike mentioned, actually, I'll walk you through a case study of how one Vermont customer improved their indoor air quality by using the approaches that Rachel explained. Okay, so this customer owns and operates a 60,000 square foot office building here in Vermont, which houses a variety of space types across 3 floors, including some open concept office space, individual offices, and conference rooms, and then a bunch of waiting areas for visitors. So during normal times, this office building is occupied by 150 employees, give or take. But however, this spring, the customer made the difficult decision to close down the building and have all of their employees work remotely in order to keep everyone safe during the pandemic. So as the pandemic continued, they began to think about a plan for safely reopening the building and bringing employees back to the office. The customer's plan included the usual: social distancing, masks, regular hand washings, increasing building cleaning and disinfection routines. And in addition to that, they wanted to leverage their existing HVAC system to maximize indoor air quality. Not only because they felt it was the right thing to do, but they also felt it was needed they needed to do everything possible they could to bring assurance to their employees that they could return safely. And then going back to what Rachel said, they wanted to integrate resiliency into their building in order to withstand this and any future challenges that we as a local community, state, and really as a global community face. So as I said, or as the slide says, the goal is to modify the HVAC system to improve indoor air quality. So now let's dive into what they have to work with. So for ventilation, this office brings in outside air through air handling units, where the outside air is then mixed with return air or recirculated air, and then distributed to each zone of the building via ductwork to variable air volume or VAV boxes. So this ventilation strategy is common in office buildings, but can also be found in hospitals, universities, and some larger high schools. For heating, they have a central boiler plant that sends hot water to heating coils in the air handling units, as well as fin tube radiation around the perimeter of the building. For cooling, this customer has a chiller which sends chilled water to cooling coils in the air handling units. Now, the customer's approach to meeting their goal, which again was modifying the HVAC system to improve indoor air quality, consisted of 3 steps. First, they evaluated their mechanical system's ability to provide good air quality. Next, they actually improved the mechanical system to enhance indoor air quality. And then they monitored the indoor air quality over time to ensure that the modifications made are working as intended. So the first step, again, is the evaluation. And to start, the customer hired a consulting engineer to assess their HVAC system. And the customer and the consulting engineer met to kick off that assessment. So the customer had to communicate what that goal was for indoor air quality to their engineer in order to make sure that they actually get what they're intending to get out of this. And that goal, again, is the modify HVAC system to improve indoor air quality. They then asked their engineer to determine the following. Can their HVAC system meet the minimum standards for ventilation? Is it as designed? So is it capable of meeting those minimum ventilation standards per the mechanical design? Then, if it can, is the HVAC system currently operating to meet those standards? And if it's not, what modifications are needed to meet the standards? And then what about to exceed the standards? And then what else should be done to improve indoor air quality as it relates to the HVAC system? So in order for the engineer to conduct their initial assessment, they needed to know how many building occupants are normally in the building, as I said, 150. How many will occupy the building during the pandemic once they bring everyone back from work? And they did a staff survey and found that about 1/3 of their staff would still prefer to work from home. So that would be about 100 during the pandemic. And then what is their long-term goal for occupancy? So once you can have visitors back in the building, what would that look like? The engineer also requested the mechanical design and as-built drawings or documents so that they can review those, and then asked the customer how they currently do maintenance of the building, what their maintenance routines are. So what type of filters do they use in their HVAC equipment? Do they have a preventative maintenance contract, and how frequent do they pursue preventative maintenance and change their filters? Next, the engineer dove into their initial assessment where they calculated how much ventilation would be required based on the area of the building and the number of occupants. So as Rachel mentioned earlier, ASHRAE standard 62.1 provides the minimum required ventilation by building type. So this is an office space, and they required 5 CFM per person and 0.06 CFM per square foot for all of these different types of office building spaces. So that's that minimum requirement that the engineer will be comparing to. Next, they reviewed the design, the as-built mechanical drawings to see if the HVAC system, again, as designed, is capable of meeting those ventilation requirements. So they compared how much ventilation and airflow is needed in each zone as a function of area and occupants to the amount of airflow that each space was designed to have throughout the air handling units and associated VAV boxes. So that's in green right here. So at this point, the engineer, their initial assessment solely looked at what was required and how the HVAC system was designed, but didn't provide much insight into what was actually going on in the building. So the engineer then recommended that the customer pursue some additional evaluations. First, They recommended that they hire HVAC and controls contractors to service and functionally test equipment. And then they recommended that the customer hire a testing and balancing contractor to measure outside airflow and air changes per hour as the HVAC system, in the way that the HVAC system is currently operating. So the customer then hired the contractors to dig into their mechanical system, and the HVAC contractor serviced the HVAC equipment, which included cleaning coils, dampers, supply and return and outside air grills, checking if fan belts are in decent condition or if they needed to be changed, if fan motors are operational or dysfunctional, and if dampers are in decent condition as well. They also identified any repair needs that existed at the time of the PM of the servicing, I mean. Then the controls contractor verified the operation of the controls for the HVAC system. So that included stroking dampers and valves, using the building management system to see if the right airflow and heating and cooling is actually happening as intended. Then they also reported out what the sequence of operation actually is in the building management system relative to what it was designed to be. And then identified any software upgrades or equipment repairs that were needed. The testing and balancing contractor then came in and measured both outside airflow into the air handling units and then supply and return airflow into each zone to then calculate the air exchange rate. Then back to the consulting engineer who reviewed all of the evaluation results and compiled those findings. So they then compared the airflow testing results with design documents and ventilation requirements in order to see if the building is, if the HVAC system is operating as designed and per ASHRAE 62.1 ventilation requirements. And the engineer also compiled all of the HVAC and control contractor reporting and documentation into one document and then provided recommendations for improvement. So I just want to stop here for a second and highlight the multidisciplinary team that was needed in order to meet the customer's goals. So of course, the customer, the owner themselves, the facility manager who oversees and supports the engineering contractor tasks, that consulting engineer, the HVAC contractor, testing and balancing contractor, and controls contractor. All of these players are integral to this, were integral to this process. And we highly recommend working with this type of team if you are to pursue this effort. So then back to the findings of the evaluation. So based on the preliminary airflow testing report and engineering calculations, the engineer determined that the air handlers are capable of providing adequate ventilation as defined by the ASHRAE standard of 5 CFM per person plus 0.06 CFM per square foot. They also determined that the boiler and chiller have adequate capacity for conditioning the air on maximum outside air, or conditioning the outside air on design days, design heating and cooling days. The engineer also noted that the air handling unit filters were MERV 8 and changed biannually. The HVAC contractor found that a plate and frame heat exchanger in one of the air handling units was plugged and had to be cleaned, which had to be done in order for the testing and balancing contractor to do their work. So that not only restricts airflow, but it reduces heat transfer from the exhaust stream to the outside air stream. and also ends up using more energy because you have to use more heat from the boiler plant. So it's great that they noted that and fixed that. Then the testing and balancing contractor, their results showed that air exchange rates to the office spaces varied widely from 2 air changes to 10 air changes per hour. So, so we want to even those out in the various zones in the building. So, and that's to ensure that everyone's breathing zone has been filtered and ventilated properly. The controls contractor noted that the demand controlled ventilation sequence was enabled. So that means that outside air dampers were at their minimum position because the building was unoccupied, and VFDs were running at minimum speed unless there was a call for heating and cooling. So they weren't maximizing the airflow that the system was capable of. In addition, the contractors noted some component failures. So 50% of the CO2 sensors were out of calibration. So even if DCV, demand control ventilation, was enabled, it wouldn't function properly. 3 of the VAV boxes had failed damper actuators, so they were not able to modulate the outside airflow as needed. And 5 of the VAV boxes, reheat coils or coil valves had failed open, so they were overheating the space, which is not good for the temperature component of good indoor air quality. So going back to those 2 pillars that Rachel mentioned for improving indoor air quality, increasing outside airflow and upgrading filtration. So that's what the engineer was focused on as they developed their recommendations. So the first recommendation for improving indoor air quality was to address the repair needs that were identified. So replacing failed damper actuators and reheat valves and those CO2 sensors that were out of calibration, and cleaning the air handling unit heat exchangers to both maximize airflow and heat transfer. Next, upgrade those MERV 8 filters in the return side of the air handling units to MERV 13 filters. And increase the frequency of changing those filters because they're going to, they would likely get plugged faster due to the smaller filter or the increased filter efficiency. Next, rebalance the air handling system in order to achieve the required outside airflow and adequate air changes or more even air changes in each space. And then add a pandemic mode to the control sequence of operation. So disable demand control ventilation for the duration of the pandemic in order to maximize airflow and outside air. And then add a sequence that drives outside air dampers 100% open if and when needed. Program pre-occupancy and post-occupancy building flushes into the control sequences in order to clean out that air, the building air overnight. And then enable trending of CO2 levels to continuously monitor ventilation and potentially even add a trigger alarm if the CO2 or potentially add an alarm if CO2 levels in any spaces rise above 1200 ppm. So the customer ended up completing all of these or pursuing all of these recommendations in order to improve indoor air quality, as I said earlier, because they felt it was important. So going back to number 3 from before, the next step for the customer was monitoring the air quality over time. So for monitoring and maintenance, the customer decided to use those CO2 sensors that they replaced as an indicator of ventilation. And they actually are thinking about deploying some particulate matter sensors or monitors in order to determine if their HVAC filters that they upgraded to MERV 13 are removing particles from the airstream as intended. In addition, they revamped their ongoing preventative maintenance schedule where they're cleaning equipment, cleaning diffusers, return air grills more frequently, identifying any faulty fan belts, motors, actuators on an ongoing basis, and then increasing those filter changes. ASHRAE recommends quarterly, but some buildings will need more than that. But that's what this customer chose to do. And then bringing this back to Efficiency Vermont's more traditional role, this customer has a plan for saving energy when they're no longer in the height of the pandemic and they don't need to operate at maximum ventilation levels. So their intention is to use a demand controlled ventilation sequence once again in their HVAC control system, which will leverage those new CO2 sensors and their variable air volume system to maintain appropriate outside airflow levels when the building and individual zones themselves are occupied, and then save fan energy and heating and cooling energy when the building or individual zones are unoccupied. So this is just one example of how a Vermont customer leveraged their HVAC system and engineering contractor resources to maximize indoor air quality. I just want to call out that the solutions that the customer ended up implementing are not pandemic specific. They're long-term solutions, and by investing in their mechanical system, they're investing in both health and longevity, as well as employee productivity. And these strategies could be applied to a variety of buildings. So not just this office space or specific HVAC system type. If you have a hospital, you could take a similar approach, but the way your outcomes, your recommendations will look differently. If you have rooftop units or unit ventilators, you can still pursue this type of approach as well. And that is the conclusion of my presentation. Mike, do you want to take questions?
Yes. Sorry, I had to get to my unmute button. I'm a little clunky with this, so I do apologize. I thought that was an excellent case study that you went through. There is one question, if I can just pull it up, please.
Mm-hmm.
Are you seeing customers that don't have a BMS that trends installing additional monitors for COVID response to be able to track ventilation or particles in the air?
Yes, we are definitely seeing customers who are choosing to upgrade their control systems in order to have trending capabilities. Some people don't have servers to store trend data. So that is one measure that we're definitely seeing some customers invest in for monitoring purposes.
Excellent. So I have to just ask the participants, if other questions have been submitted, I'm just not seeing them. I've just gotten the 2 questions that have come in from a couple of participants, but other than that, I'm not seeing anything in this or in the chat. So I'm just going to assume that there are no more questions. I thought this is an excellent overview.
We
So
do
maybe-
have a few minutes if anyone, even if someone has a specific question about their building or something, an approach that they're thinking of. Alex, maybe if you unshare your screen, we can see. Okay, that allows me to
See
any chat.
I think the chat is via the platform, not in the Zoom meeting, right?
I can't answer that. I apologize. I'm trying. but I don't see anything in the Q&A. So if any other questions do arise from this, please reach out to us. Rachel Mascolino, her name is listed there. It's rmascolino@veic.org, or Alex Rowe at arowe@veic.org. We'd be more than happy to follow up with any questions or inquiries that you have.
Oh, it says chat is in the Zoom meeting. Great presentations. Thank you, Sean.
Yeah, please
And-
don't hesitate to reach out to Alex or myself, and thanks again to Control Tech. I'm sure we'll continue to work closely with you over at least the next 12 months to make a lot of these improvements for Vermont facilities.
Yeah, just put in a personal plug as well. We certainly appreciate the partnership with Control Technologies. I've been working with them for 12 years through our customers, and it's been a very great relationship. One last thing, I'm just going to put a plug in. There are roundtable discussions later this week. They are from 11:15 a.m. to 11:45 a.m. You can find them on the agenda. The Best Practices Exchange on Tuesday. The roundtable discussion is for healthcare. Wednesday, it is commercial buildings. Thursday is hospitality, ski areas, and restaurants. And Friday is industrial. So please tune into those if you can. If there's any other questions that come up throughout this process, please just email our organizer, and we'll take it from there.
Great.
Thanks
Thank
so
you.
much, everyone, for choosing this session. We appreciate you logging in.
Thank you.
Thank you.
Thank you.
Bye.
Have a great day, everyone.